Welcome friends. Before us we have Science Paper 1 for the year 2013, and now we are going to focus on section A of this paper. So we have a car of mass 1400 kilograms, starts from rest and moves along a straight road with a constant acceleration to reach a speed of 10 meters per second in 6 seconds. Now question A. On the axes below, draw a graph of speed against time for the first 6 seconds of the motion. So the question is same as we are given some coordinates that we are supposed to graph here. Now let's see what we can gather from here. So we are told the car starts from rest. So this means that we need to begin from the initial point. So this is our initial point. So whenever we are given the point of rest, it means we are starting from 0. Then the final speed or velocity is 10 seconds, and that speed was achieved in 6 seconds. So we need to plot 6,10. So 6,10 is here. Then we are going to connect the line from the initial up to the final point, and we have to make sure that the line that we are going to draw must be a straight line, since we are given the condition of the acceleration was constant. So whenever you have the acceleration of constant, it means the line must be linear, so it has to be straight. So this is what they wanted for the first part here. So let's move on to part B. For the motion of the car in the first 6 seconds, calculate the first one, the distance traveled by the car. So we can see that this is a right angle triangle, and we need to find the base. So the base is considered from the initial point up to the final point, which is from the 0 up to the final time. Then the height is this one here. The formula for a right angle triangle in terms of distance, given the speed in the y-axis and time in the x-axis, distance is given by half, then base multiplied by h, which is distance is equal to half times the base is 6 multiplied by 10. So 10 times 6 is 60 divided by 2. We have 30 meters as our final distance. Then we move on to Roman number 2. Here we are finding the acceleration. Now the formula for the acceleration is equal to final velocity, or final speed in our case, minus initial divided by time. Okay, so final velocity is the speed it reached here at this point, which is, if we go in the y-axis, we have 10. Then the initial is 0, since it started from rest. So we have 10 minus 0. Then the time difference between 0 and 6 is just 6. 10 minus 0 is 10 over 6. Then we are going to divide 6 into 10. So I'm getting 1.66. So it is 1.67 meters per second squared. This is our acceleration. Then for Roman number 3, we are told to find the resultant force acting on the car. So we are going to use the formula from the second law of motion, which is force, or net force, is equal to mass in kilograms multiplied by the acceleration. So from the first statement here, we are given the mass of 1400, and the condition is make sure that the mass is in kg. So we have our mass 1400, then the acceleration is 1.67. So we just have to find the product of these two numbers. So 1.67 times 1400. So I'm getting the number about 2338 newtons as our final answer. So if we were to analyze the force needed for this car to accelerate with the acceleration of 1.67 meters per second with a mass of 1400, the force needed is 2338 newtons. So there is a relationship between acceleration, mass, and force, and it's given by this formula here. So the size of the force needed to produce a certain acceleration depends on the mass of that particular object. We move on to question 2a. State one difference between mass and weight. So the first difference that we can give here is mass is a scalar quantity. While weight is a vector quantity. So we can add another one. We can just say mass is constant. Mass does not change. The mass of an object on Earth is equal to the mass of the same object on the moon. So mass is constant while weight changes. It changes because the weight depends on the gravity. Then we can also give mass is measured in grams or kilograms, while weight is measured in newtons. And also mass is measured by a beam balance, while weight is measured by a spring balance. Question B, what two factors will make an object stable? So say large base area. So this is the stability. Then low center of mass, or we can just say low center of gravity. For question C, a mass of an object is 50 kilograms on Earth. What will be its mass on the moon? So given that we take this object to the moon, so do you expect the mass to decrease, increase, or to remain the same? So the mass will still be 50 kilograms. Why? We say mass is what? Constant. Question 3a. Briefly describe how the mass of a liquid can be determined. Show how the final result can be calculated. So the first one will say measure the mass of the empty beaker. The empty beaker, so the beaker will just consider as the measuring cylinder. Then second, you need to pour the liquid, the one that you are measuring. So pour the liquid into the beaker and place it on the balance, which is on the beam balance. So this time the beam balance will give the readings, the mass of the empty beaker plus that of water. So for us to find the mass of that liquid, we need to find the difference. We need to subtract the mass of the empty beaker. Since we have the mass of the empty beaker, we need to subtract it from the readings that we are going to get after we have placed the water or the liquid in that beaker. Then we'll say find the difference. Find the difference of the two masses. Then we can just say now, we can make the formula mass of liquid is equal to final mass. So final mass is the mass of the liquid plus a beaker. So final mass minus mass of an empty beaker. So we are going to use the question B for an example. So an empty beaker, relative density bottles, has a mass of 35 grams. When filled with water, its mass becomes 85 grams. So from this 85 grams, there is the mass of water plus the mass of the empty beaker. Now, since we are given the mass of the empty beaker, we can find the mass of water. So say the mass of water is equal to final mass minus mass of the empty beaker. So the final mass is this 85 grams minus 35 grams, which is the difference is 50 grams. Okay, we move on to Roman number 2. The volume of the bottle. Take the density of water to be 1 gram per cubic centimeter. So let's say we have this is the bottle. Okay, so if we can find the volume of this bottle, because volume is defined as the total amount of space occupied by an object. So in our case, if this bottle was fully filled, so the space that the water occupied is the same space of this empty bottle. Because the question is, we want to find the volume of the bottle, but we don't have the data to find the volume of the bottle. We only have the data that can help us to find the volume of the water. So we are going to find the volume of water. Then that volume of water must be equal to the volume of this bottle, because this water was used to fully fill this empty bottle. So say volume is equal to mass divided by density. So the mass, remember, 50 grams. Density, we are given, it's 1 gram per cubic centimeter. So we cancel this. So the volume of water is 50 cubic centimeters. So we'll just say, therefore, volume of the beaker is equal to 50 cubic centimeters, since this water occupied the volume of that. So that's a point. Now we move on to question 4. Figure 4.1 below shows a door well secured on the door frame. Then the first question is, what is meant by moment of force, and include its standard international unit. So we'll say moment is the turning effect of a force. It is measured in Newton meters. We move on to question B. Calculate the moment of the force if a force of 10 newtons is applied at point 1 to open or close the door. So moment is given by the product of the force and the distance. Now here, make sure that the distance is in meters. So let's go back to our diagram. So if you look at the hinge, is somewhere here. So this point is our pivot, because it's where the turning is done. Then the point of action is at this point. This is where the force is being applied. So for us to get the distance, we need to get the distance from the point of action up to the point of the pivot. So it is this distance that we are given. So we need to add 0.5 plus 0.25. So that is our distance. So the force is given is 10 newtons multiplied by 0.25 plus 0.5 is 0.75 meters. So if we multiply this, we get 7.5 Newton meters as our final answer. Then question C, explain why it is easier to open or close the door if the handle is fixed at point 1 than at point 2 or 3. So at point 1, we are going to have the greater effect. So point 1 will give us a greater moment. Therefore, only a small amount of force will be applied. So here is like a kind of a machine. So instead of applying too much of a force to do the opening or closing, we just need to apply a small amount of force. That's why we need to make sure that the distance that we have in between the pivot and the point of action must be greater. So that's a point here. For example, if you look at, if you are untightening maybe a nut, it is advisable you use a spanner with a longer handle. Why? So that it makes the work easier. Okay, we have question 5. Figure 5.1 below shows a simple bottle opener made by fixing 2 screws into a piece of wood. Then the first question is, what is meant by a simple machine? So we can say a simple machine is a mechanical device which uses less effort to overcome a huge load. Okay, we move on to question B. Which of the points X, Y, or Z is the pivot? So the pivot is where the turning is done. So this is the pivot is here, because if we are to push this down here, the turning is here, because this one will just push the lid up. So the pivot is Y. So this is our pivot. Here, this is where the effort is applied. So our Z is the effort. Then this is what we are trying to open. Our X is the load. And you need to look at the type of the class that we have. So the pivot is Y. The effort is Z. Then C is the force applied at X less or greater than the force applied at Z. So let's go back. So at Z is where we're applying the effort. So let's say, for example, if the force that you're applying here is 20 newtons, do you expect the force that should be applied on the bottle to be greater or less? Or okay, so the force that we are trying to overcome must be greater than this. So here we may get maybe 30 newtons. Why? We said in which we apply less effort to overcome a huge load. So we'll say the force at X, the force at X is greater than at Z. Then the state 1 modification that should be done on the design of the bottle opener so that less effort is used to open the bottle. So by increasing the handle, for example, if we are to extend this line here, so whenever we increase the handle, the effort that is going to be applied will be less, or we can just say we are trying to make the work easier. Then we move on to question 6. Figure 6.1 below shows how the temperature of some liquid in a beaker changed as it was heated until it boiled. So we have 20, it's beginning from 20. Then in y-axis we have temperature in degrees Celsius. Then at this point the line is moving parallel to the x-axis. Okay, then what was the boiling point of the liquid? So the boiling point is at this is where the process of boiling is taking place. So the answer is just 80 degrees Celsius. Then be state and explain what difference, if any, there would be if the final temperature, if the liquid was heated more strongly. So the boiling point would still be the same. The boiling point of a pure substance is constant, so the boiling point would still be the same, but the process would occur at a fast rate. So here, if we increase the temperature, we just heat it rapidly, we are just expecting the process to occur at a faster rate, but the boiling point will still be the same. It won't affect that. Then see, state two differences between boiling and evaporation. So we'll say boiling occurs at a fixed point, while evaporation occurs at any temperature. Then boiling occurs throughout the liquid. While evaporation occurs on the surface of the liquid. Okay, so then the other difference that we can also give is that boiling involves bubbles, while evaporation does not form bubbles. Okay, we move on to question 7. Figure 7.1 below shows an incomplete ray diagram. Complete the ray diagram above to show the position of the image. So the first step that you're supposed to do is draw the parallel line to the principal axis. Then here you need to bend, you pass through the focal point. Then the second one is draw a line that will pass through the optical center, but please make sure you use a rule. Then we can see that here the lines will never meet, but if we are to imagine behind here, these lines can meet somewhere here. So this is where we're expecting to have the image. So this is our image. Then give two characteristics of the image formed. The first one, the image is virtual. then the second one, the image is greater than the object. We move on to question 8. Start the circuit diagram in figure 8.1 below. We have voltage 4.0. Then we have two resistors, one with 3 ohms, the other one with 1 ohm. The first question is calculate the current through the battery. So current is equal to total voltage over total resistance. So we are going to find the total resistors. So say this is resistor 1, resistor 2. Now the total resistors, whenever the circuit is connected in series, it is just a direct addition. So we'll say resistor 1 plus resistor 2. Resistor 1 is 3 ohms, resistor 2 is 1 ohm. So the final answer is 4 ohms. So voltage, remember, voltage is given 4 volts over the total resistance is 4 into 4, 1. So the current is just 1 amp. And remember, current in a series connection is always constant. So at 3 ohms, the current is 1 amp, so is at 1 ohm. Then we move on to B1. How long would it take the charge of 2.0 coulombs to flow through the battery? So the formula for charge is equal to current multiplied by T. So if we make T the subject of the formula, we divide by current, here by current. So T is equal to charge over current. What's our charge? So charge is given 2.0 over current is 1. So 1 into 2.0 is just 2.0 or just 2. So the units for this will have seconds. Then for Roman number 2, how much energy would be used in moving this charge around the circuit? So energy dissipated is equal to voltage times current times time. Voltage, remember, is 4, current is 1, time is 2. So if we multiply 4 times 1 is 4 times 2, we have 8 joules. This formula can also be written as voltage. We know that charge is equal to Vt. So where there is from this formula of energy, where there is It, we can substitute with charge. So this formula is the same as voltage times charge. And what's our voltage is 4. What's our charge? Charge was given is 2. 2 times 4, we still get 8. So you can use that, depends on the information given. And sometimes you may be given resistors instead of voltage. So for that case, if you don't want to calculate voltage separate on its own, if you just want to go direct, we know that the formula for voltage is equal to current multiplied by resistance. So if we are to replace where there is voltage, this can give us energy is equal to IR times IT. So if we multiply I times I will give us I squared RT. This formula can also be used to find the energy. So the data that you are given will determine the formula that can be applied. Now we move on to the last question. Question 9a. For 1 neutron of lead, state the number of neutrons. So the number of neutrons is given by mass number or nucleon number minus atomic number. So the mass number is 214 minus 82. 214 minus 82. So I'm getting 132. Then electrons is just the number here. So this is the number of electrons as well as the number of protons. Then for the last one, lead nucleus can undergo decay by the emission of beta particles to produce a bismuth Pi nucleus. Complete the equation below to represent the decay of the lead nucleus. So we know that whenever we are dealing with the decay, mass number remains the same. So you don't have to do anything with the mass number. So 214, we still have 214 here. Then atomic number increased by 1 unit. So 82, we add 1 is 83 plus the notation for beta. So this is what we can say for this video. Thanks for watching.